Okay, students, today I want to review a little bit of what we had discussed in Unit 5, which is talking about function operations, and I'll add some new examples. And this then will roll into Unit 5.6, which is talking about inverse function. Okay, so here we go. So Unit 5-5, function operations. Now that's just a big name for it, but in other words, one could think of it as this particular unit is really about functions interacting with other functions. Okay, so that's just how you think about it, and I'll give you some examples here. Okay, the first is adding and subtracting two different functions. So that simply means you got f of x plus g of x, or f of x minus g of x. Okay, that's not too hard, right? So here you go. One example. If I give you f of x and I define that for you, this is a part of the problem: x squared plus 4x plus 1. Okay, and then I define g of x for you. G of x is 2x plus 1. Then I can give you a couple different questions. Question number 1 is f of x plus g of x is equal to what? Okay, so that's pretty simple, very straightforward. F of x, you just replace f of x with what is stated here: x squared plus 4x plus 1, plus g of x is what's stated over here, 2x plus 1. So you simply combine like terms: x squared plus 6x plus 2. There you go. Here's your answer for f plus g. On the other hand, if I ask you what's f of x minus g of x, right, then again, same thing. F of x, replace it with what is stated here, defined here as x squared plus 4x plus 1, minus, now make sure if it's minus, you put a parenthesis around it because you have multiple terms inside. G of x is 2x plus 1. Okay, so then let's simplify this: x squared plus 4x plus 1, then minus 2x minus 1. Then combine like terms, we get x squared plus 2x plus 1 minus 1 equals 0. There you go. Here is our f minus g. Okay, so straightforward, right? That's simple enough. Adding and subtracting functions. Okay, so the next one that we want to do is multiplying or dividing functions. Right? So that's the next category of examples. So here, let me give you define f of x and g of x. So I will define f of x as x minus 7, and g of x I will define as 2x squared minus 13x minus 7. Okay, so f of x times g of x is equal to, so straightforwardly, x minus 7, that's f of x, and g of x is 2x squared minus 13x minus 7. And so then you do distribution of terms and you multiply each term. So x times 2x squared is 2x cubed. X times negative 13x is negative 13x squared. X times negative 7 is negative 7x. Well, there's a minus here, so it's minus. Put a parenthesis around. 7 times 2x squared is positive 14x squared. 7 times negative 13x is negative 91x. 7 times negative 7 is negative 49. Alright, so I will combine like terms. Oh, actually, I'm going to simplify this. So 2x cubed minus 13x squared minus 7x minus 14. Now I'm getting rid of the parentheses, but I will be distributing the negative outside the parentheses. So it's negative 14x squared plus 91x plus 49. Alright, now combine like term. There's only one term of 2x cubed, so it's 2x cubed. There's the two terms of x squared, right? You got negative 13x squared, and you got negative 14x squared. Negative 13x squared and negative 14x squared together is negative 27x squared. You got two terms of x's, right? Negative 7x and 91x. Then the negative 7x plus 91x, you got positive 84x. And there's only one term with a number, so you have plus 49. So there you go. Here is your answer for f of x times g of x. On the other hand, okay, let's show you. You may not be able to see it in the frame, but there you go. Let me just pause it for a moment and leave it there for now. Okay, now on the other hand, if I were to do, let me see, I can move this over a little bit so you can see, so I have more room. So what if you have f of x divided by g of x? Well, that's just f of x over g of x. And that is x minus 7, that's the f of x on the top, and on the bottom 2x squared minus 13x minus 7. Now oftentimes this step is technically correct because you're putting in the correct form, but oftentimes algebra is about figuring out how to simplify a complex expression to the simplest possible form. So you got to think about it. This goes back to the last chapter. When you have a rational expression like this, right? You got first degree polynomial with the second degree polynomial on the bottom, and it's a trinomial, so you probably can factor the bottom. So if you think about it, surely enough, we can factor out the bottom part to be 2x plus 1 and x minus 7. And that means you can cancel out the x minus term, the factors of x minus 7, leaving it to be 1 over 2x plus 1. Now that turns out to be your f of x over g of x. So there you go. That's your answer. Okay. So now we're going to go on to a slightly more complicated operation, which is what we call the composite function. So composite function in this case, composite function. And the one good way to think about a composite function, and oftentimes it looks like this, looks like f of g or g of f. So think of it this way, is that you've had two different functions, and you take one function and stick it into another one with the rule of the other one, right? Right, the other one, right, the one that is the dominant function that goes on the outside, you follow the rule of that function, but you take the rule of the previous function and you apply it into it. Okay, if it's too confusing, don't worry at the moment. Let me show you how that works out, and you will probably get what I'm talking about. Let's take an example of f of x. We got f of x is equal to x squared. And I'm going to tell you a g of x, and that's I'll define here is x plus 1. So if I would, if the question here says find, right, or find f of g of x, f of g of x, that's the expression, and that's how you read it, f of g of x. What it's saying here is basically saying, okay, I'm going to replace what's in here with g, right? But g, what's g? G is x plus 1, right? Because it's defined right here. Do you see it? You bring it, g of x is x plus 1, so g of x is x plus 1. So you replace this with this, because essentially they're the same. G of x is x plus 1. So now, instead of f of x, you are applying f of x plus 1 now. So when you have f of x plus 1, you think of it this way. This is a sign now. When we have f of x equal to x squared, you can think of it as f of something. And whatever that something is inside that parenthesis, you apply the rule of something square. Right? This is very particular to this very particular function called x squared. So one could say f of a heart then is equal to heart square. F of apple is equal to apple square. What am I saying that for? That means if f of x plus 1, then it's x plus 1 square. You see that? So that means you take this thing and you apply the rule of the x squared and you put it in here. The x plus 1, put the whole thing inside that little x right here. So you end up with x plus 1 square. So your answer then, right, you want to FOIL this out, x squared plus 2x plus 1. So now that is f of g. Now we're going to do it the other way and see if we can apply the similar ideas to this. So find g of f of x. Okay, so in this case, right, goes the other direction. So g of, then I say, well, what do I replace with f of x? Well, in this case, you see f of x is x squared. So I replace this entirety by x squared. Right? F of x is x squared. So instead of writing f of x, I write x squared inside the g. But now let's take a look at it. G of x is equal to x plus 1. So what that means is g of something is always something plus 1. What that means is g of a heart is equal to heart plus 1. So if g is x squared, then it must be x squared plus 1. So there you go. X squared plus 1 is g of f in this case. Do you see that? This is what we call the composite function. You put something into something, and now you make a composite function. Now, let me try another one with you and make it slightly more complicated. What if you have, let's find f of g of f of x. That's a little complicated, isn't it? But that's okay, no worry. Again, let the process lead you to the answer. You may not be able to see the answer right away, but no fear. Let the process lead you to the right answer. So in this case, let me just adjust this a little bit so you can see my paper. And I will write the original equations, the defined, I'll bring it down here so you can see how it's defined. F of x is equal to x squared, g of x is equal to x plus 1. This was our original definition, right? This was given to us. So now I need to solve this. So no fear. Let's just go inside out, okay? So write out what's outside. F of g, nothing's changed, but f of x, let's change the f of x. Well, f of x is given as x squared, so I will replace this as g of x squared. So now it's f of g of x squared. So now, again, no problem, f of, now the question is what's g of x squared? Now remember, g of x is equal to x plus 1. G of heart is equal to heart plus 1. G of x squared is x squared plus 1. So there you go. G of x squared is x squared plus 1. So then the next question is, what is f of x squared plus 1? Now remember, f of x is equal to x squared. That means f of heart is heart squared. That means f of x squared is x squared squared. That means f of x squared plus 1 is x squared plus 1 squared. You get it? So f of x squared plus 1 is x squared plus 1 squared. Now all I need to do is to simplify this. This is a binomial expansion. So it's x squared plus 1 the parentheses squared, right? So it's x squared squared plus 2 times x squared times 1 plus 1 squared. We get x to the 4th power plus 2x squared plus 1. That is f of g of f. I won't solve this one here for you, but I leave this to you to solve on your own. Find g of f of g of x. I'll give you the answer. The answer is x squared plus 2x plus 2. See if you can come up with this answer. Okay? And in the next video, I will talk about the inverse functions.